Hello guys, today we're going to study a system of linear equations in two variables. Example 1, determine whether ordered pairs are solutions of a system. Here we have a system equation, and then we have part A. For this type of questions, really straightforward, because we know this is your x and this is your y. All you have to do is just plug it in. Okay, so x is 4, right? 4 plus 2 times -1. So you're going to check, is it going to give you 2? If you look at this, that will be 4 plus -2, which means this is true. So then we also look as here we have x minus 2y, so we're going to plug in again, and that will be 4 minus 2 times -1. And then see it's going to give you 6 or not. So this is going to be 4 minus 2 multiplied -1, that's just going to be 4 plus 2, that will be 6. This is true as well. So then we say this pair is, yes, is a solution. So for part B, we do exactly the same thing. Alright, so you plug in your x and y, and you're going to see here we have -4 plus 6, so equals 2, that's true. And then here we have -4 minus 6, that's -10, that's why it's false. So that is not a solution. For example 2, solving a system by substitution. Okay, so if I have something like this, let's say this is my first equation, and here we have a second equation. So solving by substitution, you really have to pay attention for what kind of method you want to use. Okay, so if you use the wrong method, so you get no points for your test or quizzes. So let's go ahead and look at how I can solve this. Let's go ahead and rewrite the equation 2. So x equal to 2y minus 3. So once we have this, alright, so all we have to do is we're just going to plug this whole thing, replace x for your equation 1. That will be 5 times, okay, our x become 2y minus 3, and then minus 4y, and then equal to 9. Remember, this is just going to be replaced for your x right there. Alright, replace your x, and then my y is 4. So now I'm going to substitute back here and find my x. My x equal to 2 times, alright, substitution, 2 times 4 minus 3 equals 5. So I can write my solution as 5, 4. So of course you can just go ahead check your answer by using the method we have explained in example 1. This one we want you to use the addition method. You have to read your question. Okay, if you don't read your question, you get it wrong, then you're going to lose all the points. For this question, so if we look, we can actually multiply the equation 1 by 4. Okay, remember the goal is you multiply something and then you make one of the variable disappear. You know, when you're adding them, you're going to make one variable disappear. Okay, that is the goal. So if I multiply 4 for the equation 1, okay, this is going to become 8y. We have positive 8y and then we have a negative 8y. That's why when we add them, they're going to be gone. Okay, no change for this second equation. 4 times 3 is 12x, and then plus 8y, and then 4 times 48 gave you 192. So once we have this, so I'm going to write it right here. We're going to add them together. That will be 21x. This is going to be gone because they're going to be ax and then minus, no, excuse me, that is 8y and then minus 8y, they're going to be gone. And then here we're going to add them together. That will be 168. X equal to 8. Once you have your 8, and then you can bring this back, separate back either first equation or second equation and solve for your y. So I'm just going to plug inside the first equation. All right. So that will be 3 times 8 plus 2y equal to 48. Y equals 12. And then we have our solution, 8 and 12. Be careful this, okay? You're always going to have the older pair. So your older should be always x and y. sometimes you're going to get y first. You still have to write this order. Example 4, we're going to solve again by the addition method. So let's go ahead and take a look. So for this question, before we do the addition method, we'll rewrite as a system. So let's make sure we're going to write 2x. And then let's go ahead and move this to the left side, the equal sign. That will be subtract. Okay, going another side, it become minus 7y and then equal to negative 17. Then for the second equation, again, let's move this x to the front, negative 3x. Go to another side, so it become positive 3x. I didn't change the y anywhere, so I'm just going to say plus 5y and then equal to 17. Step 1, I rewrite it in the order x, y. Order look on the same line. Okay, this is equation 1 and equation 2. Okay, so let's go ahead and look at what should I do. And then try to use the addition method. So my goal is, here we have 2 and 3 and 7, 5. So let's just go ahead and get rid of x first. We need to multiply the first equation by positive 3. And then the second equation, we're going to multiply by negative 2. The reason why we do this, if you think about it, if I multiply 3, this will become 6x. And then multiply negative 2, this will become negative 6x. And then once we have this, we're going to add them together and create a 0x. That's why we did this, alright? Okay, let's go ahead finish this up. We created a new system, and then we're going to add them together. Okay, this is going to be gone. This is going to be gone. That will be 0x, and then here we're going to have negative 31y, and then equal to, this whole thing going to be negative 85. So then we're going to have y equal to 85 over 31. Let's go ahead and see if we can simplify. We can't. We're just going to leave it this. We're going to step this back to equation 1. It's just a fraction. All you have to do is just being a little bit patient, okay? If I want to draw a line, so all I'm doing is bring this back to the equation 1 for, right? And then you plug your y in there, and then we solve for our x. So now we just have to simplify a little bit, okay? So you have a calculator. You can totally simplify this, not that too bad. We're going to have 2x minus, okay, and then you use 7 times 85, you're going to have 595 over 31, because I can just write this as 7 over 1, you multiply. Okay, then you're going to have negative 17. So then we're going to have 2x equal to, so we're going to have negative 17 plus, because moving this to another side, okay, that's the whole thing. And then you just have to simplify this by rewrite, I'm going to write it right here, rewrite negative 17, alright, because we want to have a denominator of 31. That means you have to multiply 31 over 31. That's where this comes from, 527. So once we have this, we're going to use this number, negative 527, that's over 31. Now it's a plus 595 over 31. So again, you have a awesome calculator. If you don't want to do it by hand, perhaps you can do this by hand, okay? So then we're going to have, okay, I'm going to write it down. That will be 68 over 31. So divide by 2 both sides. So which I have. So this is going to be gone, and then dividing by something just the same thing as multiply the reciprocal. So now you have 68 and then you have a 2. So we have simplified this. That will be 1. This is going to be 34. So which means your x equal to 34 over 31. So your final solution is 34 over 31. That's your x value, and your y value is 85 over 31. So that is your answer for this example. Alright, let's go ahead and move on. So here we have a few graphs. if you look at this graph, anytime actually you have a system, you pretty much can check your answer by using your graphing calculator. So here, if a graph like two line, they intercept two linear equation, which is a system equation. If you have a two linear, right, they intercept, then that means there's exactly one solution because it's only intercept one time. Okay, so here we have this right there, is that means one time is exactly one solution. So if they're parallel, which means they never meet, so there's no solution because they never meet. And then here we have overlapping, that means there are many solutions because they're overlapping. So let's go ahead and look at example 5, a system with no solution. So we're gonna just go ahead and solve this. Okay, if you solve this by using addition method, for example, so I add those two together, I realize this side is going to become 0, then here we're going to have a 12. Okay, if I add them. So this is always false, right? This is a false statement, which means there's no solution, right? If I'm write it down, therefore, no solution for this system. Okay, because no matter what, you're gonna get false statements. Okay, example 6, a system with infinite many solutions. For this one, I could just, if you look at y, right, it's right here. The easiest way for me is I'm just going to do a substitution. So I'm going to have a 15x minus 5 times 3x minus 2 equal to 10. Then I'm doing a distribution. I'm going to have 15x minus 15x plus 10 equal to 10. This whole thing going to be gone. Then I'm going to have 0x plus 10 just equal to 10. Then I realize this is always true. Alright, my variable is gone, but this is always a true statement. Therefore, there are infinitely many solutions because no matter what value you plug in for x and y, this statement always true.